22. This is just a quick update on my solution. So I gave up on the search algorithm that I was working at, and I sort of took a cue from their problem description, and I said, can I render this? Can I render this in a visual way? So I wrote this function here, which renders the state of a state of the search space. So if I were to render the starting state here, then I would get. Oh right, I will want to print line it. Then I get sort of this this grid-looking thing where all of these nodes are basically interchangeable, except there are some nodes in here forming kind of like a wall that I need to go around. There's only one node that can really receive data. So what I essentially have to do is I have to sort of move this hole all the way up to next to the goal data and then shuffle it over. And what I did was I wrote this sort of move data command, which moves data from source to a destination. Then I wrote a move function, which takes a direction that you want the hole to go in, and then it moves the data based on where that hole is. And then I just started basically doing a print line of rendering reduce using move from starting state to say like, okay, I want the hole to move up, let's say. And then so when you run this, you can see that the hole here has moved up one closer to like this wall right here. Then I just go around the wall, back up to here, and then so I just sort of did this like one step at a time. Then once you get to this point, I'll demonstrate what this looks like. Once you get to the point where the hole is next to the goal data, then you can use like this little algorithm where you basically shuffle the data over, then move the hole back in front of the data again. So each time you run this, the data ends up moving one to the left, and then finally, so you have to do that for like 31 times or something. Then at the very end, you just have to move the data over once, and then you can see when this gets run that goal data, the node that we want it to be at, and then there's the empty space. So then all I had to do was do a count of my algorithm for solving it, and I'm going to have a high level of confidence that this is the minimum number of steps taken, because I mean, obviously we need to take one step. It's a one step to get up into our starting position, and then yeah, there's just not really any room for optimizations there. So yeah, so in the end, it turned out that the data and the sort of disk sizes, they were a little bit of a red herring, which was cool. So I was able to plug in my answer and get my stars. Yeah, I think that the lesson sort of that I can draw from this is, to take the visualization seriously, because this didn't take a very long time to code up. Certainly less time than I spent on an incomplete and probably buggy A-star search algorithm. So yeah, that just shows you how sort of examining the problem in a little bit more detail and trying to get a feel for it can often lead to insights. So all right, that was just a quick update today. We can see our advent calendar is almost full. Day 23 is starting in about 18 minutes, and I'll be back for that. But I just wanted this to be a quick update on how I ended up solving the second half of day 22, and I will see you in 18 minutes. Thanks for watching.